In 2025, enterprise AI adoption has officially doubled compared to last year. Nearly a third of prioritized AI use cases have moved out of the testing phase and are now in full production. Organizations are aggressively steering these new deployments away from standard back-office efficiency tests. The focus has shifted directly toward revenue-adjacent functions, specifically CRM automation, sales enablement systems, and lead capture. The financial commitment behind this pivot is substantial. Enterprises are spending an average of $1.3 million per prioritized use case to push these specific initiatives forward. Yet, the results reveal a massive disconnect. Despite pointing millions of dollars at sales and customer acquisition pipelines, actual returns on revenue growth and staff reduction are drastically underperforming executive expectations. Only about 1 in 4 of these initiatives is meeting its growth targets. We are looking at a clear ROI paradox. Enterprise AI value is currently scaling inversely to executive ambition. The more capital organizations direct toward complex, revenue-generating functions, the harder it is to realize a return. To see exactly where the technology is actually delivering on its promises, we can look at the empirical data from the 2025 ISG State of Applied AI study. This chart tracks AI performance relative to expectations across the enterprise. The clear leaders at the top are research and development, risk management, and compliance. These functions are consistently beating their targets. Look at the bottom of the exact same distribution. Direct cost savings, revenue growth, and staff reduction represent the deepest negative bars on the board. The initiatives getting the most executive attention are failing the hardest. Risk management and compliance succeed because they operate in highly structured environments. The data is pre-cleaned. The workflows are strictly defined, and the AI acts to strengthen an established process. Growth and customer acquisition initiatives attempt to operate in complex, highly dynamic environments. They rely on unstructured, multimodal data across fragmented platforms, lacking the rigid guardrails required to ensure accuracy. The paradox exists because organizations are funding dynamic orchestration capabilities, but their internal governance systems are only mature enough to validate predictable, rules-based tasks. The IT department serves as the clearest microcosm of this pilot-to-production scaling chasm. Compare the adoption metrics of 2 distinct tools. On the left, AI copilots generate a massive volume of use cases, yet a fraction of them actually reach full deployment. On the right, anomaly detection models have a very small footprint of initial use cases, but nearly half of them successfully scale into production. Copilots attract massive initial investment because they promise immediate productivity gains for developers and support staff without requiring changes to the underlying infrastructure. That ease of entry leads to broad penetration, but the lack of deep integration causes deployments to stall as they face reliability issues in live environments. Anomaly detection models scale reliably because they operate entirely on rigid, highly governed network and system log data. The parameters are locked down, allowing the model to produce precise, verifiable outcomes. The dividing line is data readiness. There is a massive structural difference between processing strictly structured, numeric inputs and trying to safely parse volatile, multimodal, unstructured conversations. High-visibility generative tools hit the production wall because they lack rigid operational constraints. Low-visibility predictive models thrive precisely because those constraints are built into the data itself. To understand this maturity mismatch, we must look at how artificial intelligence actually generates value. It does not happen all at once. It evolves through specific operational eras that layer on top of each other. These 3 eras are prediction, creation, and orchestration. Each requires an entirely different foundation of data and governance to function. The traditional prediction era relies on pre-cleaned, curated datasets. Because the outputs are used for narrow, reliable functions, like fraud detection, the governance structure depends on manual validation and clear data ownership. The generative creation era increases the potential speed and breadth of tasks like drafting text or summarizing calls. However, this relies on massive pools of unstructured data, decreasing operational control and introducing the risk of hallucinations, which forces teams to rely on post-output reviews. The agentic orchestration era expects systems to make real decisions and execute tasks autonomously. This demands dynamic, raw application data and instantaneous inline validation, because the model operates on invisible data dependencies, where failures execute immediately.
The root cause of the current ROI disconnect becomes obvious to us. Enterprises are attempting to deploy agentic ambitions while relying on predictive governance frameworks. That mismatch guarantees failure at scale.
Bridging the chasm from basic prediction to full orchestration requires organizations to abandon single-model thinking. The solution is building a multi-layered ecosystem. What looks like a single enterprise application must be broken down into distinct integrated components: the consumption interface, the underlying models, the data pipelines, and the physical AI infrastructure. The crucial bridge between the data and model layers is MLOps. This continuous operational loop manages model training, tuning, and performance monitoring, connecting isolated experiments into scaled, compliant enterprise systems. Implementing this stack forces leadership into a primary operational roadblock: the decision to build a custom solution or buy pre-built enterprise software. Purchasing pre-built enterprise software accelerates time to value. Vendors provide built-in capabilities, immediate guardrails, and assume responsibility for model maintenance. However, adopting the exact same off-the-shelf tools heavily limits any chance of competitive differentiation. Building a custom architecture allows an organization to fully differentiate its services and optimize for its specific data. The trade-off is that the enterprise must solve the massive governance and talent gaps entirely in-house. Scale proves impossible without an integrated architecture. Organizations must treat data readiness, the model lifecycle, and compliance governance as a single, indivisible operational unit. Moving these complex, multi-layered ecosystems out of pilot testing and into production reveals a harsh financial reality. Many teams operate under the professional misconception that purchasing an AI agent is financially equivalent to buying a standard software as a service subscription. Beneath a flat base license fee lies a cascade of hidden costs. It begins with IP creation and fine-tuning. Then comes unpredictable token consumption. Finally, organizations must account for specialized compute infrastructure and perpetual monitoring. Evaluating artificial intelligence ROI solely on licensing guarantees what experts are calling cloud sprawl 2.0. Without rigorous financial operations discipline, these compounding hidden costs will quickly devour any promised margin improvements. To properly align risk, cost, and value in 2025, the market requires a strategic shift in how these systems are contracted. The solution emerging to address this is autonomy-level pricing. Instead of billing for software code delivered or raw tokens consumed, this model maps financial charges directly to the system's level of operational independence and the actual work executed. By tagging resource units with specific autonomy tiers, the contract properly distributes operational risk between the provider and the enterprise, rewarding actual workflow efficiency rather than mere capacity. The path forward requires moving away from isolated, predictive pilot projects and integrating these capabilities into a unified, autonomous enterprise architecture. True return on investment is never found by chasing the latest hype surrounding autonomous agents. It is achieved by rigorously matching a specific use case to the organization's verified maturity in data design, dynamic governance, and financial